Hello dear students, welcome to Pen and Paper Chemistry on YouTube.
Hello students, welcome to the channel
Pen and Paper Chemistry.
Topic we are doing today is Hess's law of constant heat summation. That is the 10th video in the series Thermodynamics. Hess's law of constant heat summation is nothing but what you have already been doing in mathematics. So I've taken a very simple example over here. 7 can be expressed as a sum of two numbers. For example, 1 plus 6, 2 plus 5, 3 plus 4. So very easy. If I give you A plus B gives me 7 and I tell you that A is 5, so you can very easily determine the value of B from here. The same logic we are going to apply in the Hess's law. Simply put, this law states that if you carry out the process in one step or a number of steps, the enthalpy change during the entire process remains the same. So, if I convert carbon to carbon dioxide, the enthalpy change in this process is negative 393.5 kilojoule per mole. Okay, tell me, conversion of carbon to carbon dioxide, is it an exothermic or an endothermic process? Yes, it's exothermic. This is indicated by the negative sign for enthalpy. The same conversion can be achieved by converting carbon to carbon monoxide and carbon monoxide to carbon dioxide, all by the process of oxidation or combustion. Now, it is difficult to control the oxidation or the partial oxidation of carbon to carbon monoxide. This is easy. We can determine carbon monoxide to carbon dioxide. This combustion can also be determined by the value of delta H. We have done the methods of determining the value of delta H, that is the enthalpy or the heat energy change when the process is carried out at constant pressure. Please refer to the earlier videos. We have discussed the methods to that. Now the glitch comes here when you are not able to determine this because it is difficult to control the process here. So what do we do? Now here I don't know this value. I know this and this. So you know A plus B is C. You know the value of C, you know the value of B. Can you determine the value of A? Yes, as simple as negative 393.5 is nothing but the summation of negative 283 kilojoules per mole plus the delta H naught value for this particular process. And that gives us the value of negative 110.5. Thus, whether you carry out the process in one step or a number of steps, the total enthalpy change remains the same. Now, this concept is very, very easy from examination point of view, from understanding point of view, from application point of view. It is very, very important as well. If you understand the numericals based on this, then it's very easy to score marks in this particular numerical. But it's just that we have to decipher the statement of the question very carefully, convert it into the language of chemistry, or more specifically the thermochemical equation, and you get the answer well in just one step. So let's start. Let me teach you how to decipher a question and convert it into a thermochemical equation. Given to me here is standard enthalpy of combustion of carbon and methanol is negative 393.5 and negative 726 kilojoule per mole. Since this is enthalpy of combustion means burning. Heat is always liberated. That is why these values are negative, indicative of an exothermic process. Let's convert this into the thermochemical equation. Now we are talking about standard. That means the reactants and products are in their standard state. So carbon, graphite in the form of a solid, Oxygen gas burns to give you carbon dioxide. You have to remember, because it is standard, so how many moles of carbon can we take over here? Yes, 1, because we're talking about standard molar enthalpy. That means the enthalpy of combustion of 1 mole of the substance. So the enthalpy change is written over here, negative 393.5. Enthalpy of combustion of methanol, CH3OH plus oxygen, any hydrocarbon on burning gives us carbon dioxide and water, all in their standard state. Enthalpy change given as negative 726. If you notice, we put a small c over here, indicative of the process of combustion. Come to the next statement. If the standard enthalpy of formation of water, that means when 1 mole of water is formed from its elements in their standard state. So, hydrogen gas plus oxygen gas gives us water liquid. The enthalpy, the standard enthalpy of formation is negative 286. Now, if you notice over here, we cannot change the number of moles of water molecules over here because we are talking about standard enthalpy of formation of water. So, in order to balance this equation, there's oxygen 1, whereas oxygen was 2. If supposing I do not consider this balancing, hydrogen 2, correct, balanced. Oxygen 2, oxygen 1, so unbalanced. So, what do we do to balance? We can't put a 2 over here like we would have done otherwise in simple balancing, because then we have to multiply this enthalpy value also by 2. So either you do it that way, or alternately a simple way is we just balance it by putting a fraction over here. What do we have to find out? What is the standard enthalpy of formation of methanol? So I want how much enthalpy change takes place when methanol is formed. 1 mole of methanol is formed in its standard state, which is CH3OH in the form of a liquid. Enthalpy of formation, that means enthalpy change when 1 mole of a substance is formed from its elements in the standard state. So carbon graphite, hydrogen gas, oxygen gas gives us CH3OH. Again, we just need 1 mole of CH3OH. So let's balance it. 1 carbon, correct. 3 plus 1, 4 hydrogen. So we put a 2 over here in order to balance this equation. 1 oxygen atom over here. So in order to balance it, we put a fraction over here. We will not put a 2 because then the value that we will get will not be the enthalpy of formation of methanol. That will be the enthalpy of formation of 2 moles of methanol. Now, this is what we want to find out. So this is what, let's call it as our target. Right? Now we need carbon graphite solid. Yes, we need carbon graphite solid. We need 2 hydrogen atoms on the left hand side. I've got only 1 hydrogen on the left hand side. So what do? In order to get 2 hydrogen, let's multiply this whole equation by 2. So when I multiply this whole equation by 2, please remember that the value of 286 will also get multiplied by 2. Now, so what do I have after first and the second equation? We can add them up. Let us see what we have. So we have carbon in the form of graphite and it's a solid, plus 2 hydrogen, plus now oxygen here and an oxygen here. 2 into half gives me 1 oxygen, plus 1 oxygen gives me 2 oxygen here, right? At the same time, on the right hand side, we've got carbon dioxide gas, water liquid, and how many of water liquid? We've got 2 water liquid, right? Here I have not put the standard states. It should be understood. Now, in this overall process, I'm getting carbon, hydrogen, but I haven't got methanol on to the right hand side. There are 2 ways that you can do. Either you reverse equation 3 and add it up, in which case I will have CO2 plus H2O gives us CH3OH plus oxygen. Now, if you notice over here, even this third equation is not balanced. So, because we're talking about the enthalpy of combustion, I cannot touch the methanol. So, carbon 1, hydrogen is 3 plus 1, 4, hydrogen is 2 over here. So, let us make it as 2. Oxygen is 2 on the left hand side. Oxygen is 2 plus 2, 4 on the left hand side. On the right hand side. On the left hand side, it is 2 plus 1, 3. We want to make it 4. So, what we do is by 2. So, when I reverse it, this becomes 3 by 2 O2 on the right hand side. And the value of delta H becomes a plus. I add these three equations. So, we get carbon dioxide, we get 2H2O, we get CH3OH on the right hand side. That's a liquid. And by 2 O2. Now, let's see. We are getting carbon dioxide in the reactant, carbon dioxide in the product. 2 water on the left hand side, 2 water on the right hand side. Cancel. There's 2 oxygen and that is 3 by 2 O2. So what do we have is, we are just left with 1 by 2 O2 over here. So what did we do? We took the first equation, we took the double of the second equation, and we subtracted the third equation, or alternately, we reverse the third equation. So how do we write our calculations? So if you notice, we've got the final equation, carbon, graphite solid, plus 2H2 plus half O2 gives us CH3OH liquid. Let's find out the delta H naught value from this equation. You got the first value, negative 393.5. Correct. The second value we had multiplied by 2. So negative 286 multiplied by 2. You had reversed the third equation. So plus 726. When you calculate this entire value, you get the enthalpy of formation of methanol. Can you do the calculations for me? And before I write the answer, let us see if our answers tally. Please go ahead, do the calculations. Negative 239.5 kilojoule per mole is the standard enthalpy of formation of methanol. So what you have to do is just keep the target equation in mind and either add or subtract the equations. Once you have two equations in front of you, you would know what to do with the third equation. It gets very confusing. You'll feel nervous when you add the two equations. Oh, I've got carbon dioxide and water on the right hand side. I don't need them. What will I do with them? Don't worry. Don't panic. Relax. Go on to the third equation. Either you can subtract the third equation, or you can say that we take the reverse of equation 3. How will you write this particular step? You will simply say equation 1 plus twice of equation 2 minus equation 3. Right? Always remember, when you are subtracting, the sign will change. This is the rules of algebra, if you remember. Or when you are reversing the equation also, if the forward process is exothermic, let's suppose I have this equation, the forward process is exothermic, then the reverse process is endothermic. In order to get a better grasp and understanding of this topic, please attempt at least 5 numericals based on this. Any doubts, you are most welcome to clear your doubts either through the YouTube channel Pen and Paper Chemistry or through the mail ID that is shared on the YouTube video. Happy studying.
The only mission of this channel is to make learning chemistry easy and fun for all you students. With the help of the periodic table, the flowcharts, the graphs, diagrams, dealing with numericals, how to deal with numericals. And this can only happen when you keep a pen and notebook ready so that you can also take down notes for offline reference. There is no subscription to join the channel. There is no payment at all. Only request is to help spread a word about the channel by sharing it with friends, classmates, juniors, seniors, so that chemistry can be easy and fun for one and all. See you in the next video.